We're going to look today at data analysis. Not so much of looking at the end result of whatever test you're running, but understanding your data and making sure that it's accurate. If you've ever heard the term from computer programming, garbage in, garbage out, the same applies to statistics. If you do not have clean data, whatever test you run on it is not going to be any better. What I have done on the sample that you see in front of you is we've run height, weight, and temperature of 11 different patients the nurses had that day. The first thing you're going to notice, if you look at line 13, is the averages for those 11 people. What catches my eye first is a temperature of 84.93. That seems terribly low. Granted, I'm not a nurse, but I would be concerned if I saw temperatures of 84.93. So I'm going to look over the data and see if there's something that's going to come out and hit me suddenly. First thing I notice is a temperature of 37. Now, why would I have a temperature of 37? So I looked at the other data that was also involved in that particular sample piece, and it had a weight of 77.11 and a height of 1.83. What I realized is someone entered it using the metric system as opposed to using the standard English. That's exactly what I told them to do in regards to don't convert any of your data, enter it however you would normally enter it. And this particular agency used metric for whatever reason. Now, if I convert it to standard English, which is what everything else is in, we'd go to a height of 72, a weight of 170, and a temperature of 98.6. That reflects a little bit better of what I would have thought, but if you still look at the average of the temperature, you're still seeing only 90 degrees, and that still seems terribly low to me. Well, if you looked at the item just above the average, it says 9.68. There's a concern. It should have been 96.8, but I'm a lousy typist, so it came out with a decimal place in the wrong point. Decimal point in the wrong place. That looks much better. Now, it would be fair to look at the data and confirm that all the 98.6s or the 96.8s are all accurate. The reason being both are valid temperatures, and you want to make sure that your data is accurate all the way through and that you haven't transposed a number. Going to the height column, the first thing that stands out is the fact that this 5'6" is over to the left as opposed to over to the right. The rest of the numbers are lined up. And that's simply because when there's any kind of punctuation, the computer is assuming that is an alphanumeric and not a numeric item that should be calculated. If you take the 5 feet 6 inches and convert it into 65, then you're going to see a difference there as well. Now other things look reasonable. If you're looking at an average height of 63 inches, that's 5'3" inches. Okay, that means you have mostly short patients. And if you're looking at an average weight of 355, then you have short, heavy patients. So I want to think about that, and is that what I'm seeing here? If you glance down, you're going to come across to line 7 where it shows 22 inches for height, 16 pounds for weight, and 101.4 temp. That means somebody saw a pediatric patient that day if this is accurate. Question comes is, what is this data supposed to be reflecting? If this data is about a nurse practitioner who is a family nurse practitioner and deals with all kinds of patients, and she only had one patient who was pediatric that day, it was a relatively newborn baby, and then that information may be accurate, but is it really helpful in this particular circumstance? Or did someone want to separate pediatric patients from adult patients? Maybe this needs to be taken out and put in with that group of patients. We're going to assume that. Maybe there's a second study being done and we really don't want pediatric patients in here. We're only going to look at adult patients. So let's see what that does. So that gets my height up to 67 inches, I'm sorry, and that makes that much shorter rather than 5'7" as opposed to the 5'3" that we were looking at. And we did raise the weight a little bit. So that still gives me a little bit of concern. And then I noticed there's another typo. I haven't met too many people that weigh 2,000 pounds. I know it's possible, but I haven't seen too many of them yet. So I'm going to go back to my data and realize it should have been 211, not 2,011. So that is going to make a significant difference in looking at my weight. So this is a reason that you have to check and make sure that you know your data so that you can see that accuracy is foremost, that you make sure that everything works the way it's supposed to. You only get garbage out if you put garbage in. Thank you.